All right, so today we're going to be talking about a new type of graph, which is the cube root function. So we've already done the square root function before, but now we're going to do cube root. Okay. Now the apparent equation for the cube root function looks very similar to the square root function. We have f of x is equal to the cube root of x. Okay. Now, for this, we're actually going to kind of graph this a slightly different way than we've graphed before. Okay. So, just to kind of give you guys an idea, so why that we're going to do it like this, I'm just going to write this over here. If we were given the function, so let's just say f of x. Well, I don't know why that's looking like that. Sorry. We're given the function f of x is equal to x to the third. Okay? X to the third. If I wanted to find the f inverse of x, right, I know that this would be y is equal to, y is equal to x to the third. Switch my x and y. And then I would take the cube root of both sides. And so that I know that y would equal the cube root of x, which means f inverse of x is cube root of x. Okay? So we're going to use that idea in order to graph this. Okay? Instead of doing our normal table of values, and you can do the table of values if you want, I just want to show us a little bit different way. Okay? So the first thing I'm going to do is I'm going to label my graph. My y, my x, 1, 2, 3, 4, 5, 3, 4, 5, 1, 2. And you guys should be doing this on yours as well. 10, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm sorry, that should be up here. Okay. So I'm actually in blue. I'm going to go ahead and I'm going to graph this function. I'm going to graph x cubed. Okay, so this is one that we've seen before and we know before. So when we had x cubed, we started at 0, 0. That was our point of inflection. Okay? And then we went up, right 1, up 1, left 1, down 1. And then when we go, the next part that we actually have something. So if I go over 2, 2 cubed is actually 8. So I go 2, 5, 6, 7, 8. I go left 2, 5, 6, 7, 8. Okay? And remember that the reason that these negatives work, right, is because I can, if I do a negative value cubed, I'm still going to end up with a negative value. Okay? And so our graph looked something like this. Okay? And since 3 cubed is 27, we know we're never going to quite get to 3. And so this is our function x cubed. Now, what we talked about the other day when we were talking about how to graph inverses, okay, since we just showed over here on the right that cube root function is actually the inverse of the cube function, right, I'm going to kind of use that idea. Okay? So what I'm going to do is, since how we actually solve these and graph these is we notice that, hey, you know what? A function and its inverses, right, they're the exact same thing, just reflected across the x, or sorry, again, across the line y equals x. So I'm actually going to graph the line y equals x in here, which again starts here, here, here. And just has a slope of 1, passes through the origin. Okay. And this is my line, y equals x. Okay. I'm going to reflect this function across that line. Okay? Now I'm going to use red for this one. So a couple things that you're going to notice is we actually have these 3 points that are on this line. And if you remember anything from geometry, right? If my points are on the line of reflection, right? That's where the other graph kind of touches. That's where the pre-image and the image, that's where they intersect. Okay, so this thing's actually, these two are going to actually intersect at these 3 points. Okay, now since this point up here, right here, was at 2, 8, and this point right down here was at -2, -8. In order for me to reflect these across the line, or the y-axis, or sorry, the line y equals x, right, I have to switch their x's and y's. Because remember, my transformation rule for reflecting across this line is xy goes to yx. Okay? So, to graph this, I'm now going to take this 2, 8, and I'm actually going to go 8, 8, 2. Okay? I'm going to do the same thing with the -2, -8. Now I'm going to go -8, -2. Okay? And you'll see kind of what this graph starts to look like. It's the same thing, just kind of rotated on its side. Sorry, my sketching skills aren't that great. And so here we have our graph. F of x is equal to the cubed root of x. So, and that's our function. Okay? Now, what you want to write down for the verbal description, that's all entirely up to you. I just use that kind of for the notes thing. So if you wanted to say that it looks like a sideways snake, it looks something like that. It looks like the cube root, just if I took the whole thing and I rotated it kind of 90 degrees almost and then flipped it, right? However you want to word it, right? That's up to you, right? But that's kind of the verbal description. So now let's talk about the defining characteristics, okay? So who can tell me what the domain of this function is? Or again, we're looking at the red one. Who can tell me what the domain of the red one is?
All real numbers.
What is it?
All real numbers.
All real numbers, or remember that the terminology we use, we go from -infinity to +infinity. Okay? So, and the kind of remember the reason why, if I look at the domain for x cubed, right? Right? My domain for x cubed is -infinity to +infinity, and the range is -infinity to +infinity. Okay? So remember, when we do inverses, these two are supposed to switch. Okay? So, but since they're both pretty much the same thing, we know that our domain is -infinity to +infinity, because that's what the range of our inverse used to be. And then our range now is going to also be -infinity to +infinity, because that's what our domain of our pre-image was. Okay? Now, is this function, so when you're looking at this function, is it always increasing or is it always decreasing? Or does it look like it changes up everywhere? What's that? All right, changes. It's actually always increasing, because again, to determine that, where do we go? Here we go. Determine that, remember, we go left to right. We go left to right, and we see, again, we're following the red here, right? We can see that it's constantly going up. Constantly going up, going up, going up, going up. That means it's always increasing along my domain, okay? So the interval which it's increasing, right? Oh, whoa, whoa, what? No. Whoa, what just happened? There we go. That was weird. So we know it's increasing on the entire domain, and it's never decreasing. Horizontal asymptotes and vertical asymptotes? Nada. Okay? We'll get to the x and y intercepts in just a little bit. Okay? So, maximum value, minimum value. Do we have a max or min Anywhere? No. We have no maxes and we have no max or no min. Okay. Is it 1-to-1? Here's the trick, guys. So this is kind of what we tried to show with the last set of notes. Okay. So remember that 1-to-1 means. So we're going to look at the blue one. Okay. So looking at the blue one, so if I go the vertical line test, this tells me that, yep, this thing's a function because my graph never touches this ruler in more than one place, okay? Now to determine if it's 1-to-1, right, I use the horizontal line test, and I go up, and we see that the graph never touches it in more than one place. So this function is 1-to-1. Remember that the only graphs that have actual inverses are graphs that are 1-to-1. So when we looked at quadratic functions, quadratics are not 1-to-1. And they didn't have a technical inverse, right? Because the square root function is only half of a parabola. So it's not a true inverse. So because this one has a true inverse where I didn't have to restrict the domain or anything like that, right? This function has also got to be 1-to-1. They both must be 1-to-1 in order for us to have a true inverse. Okay? Slope, nonlinear, vertex. Remember, we're not going to call this the vertex. We're going to call this the point of inflection. Right? And the point of inflection here is at 0, 0. There's no axis of symmetry. Okay? And now we're going to talk about the x and y intercepts. Okay? For these, so understand that x and y, if we knew what the x-intercept is for this original function, for x cubed, which in this case was 0, 0 for both, right? Then they're actually going to switch. My x-intercept becomes my y-intercept, and my y-intercept becomes my x-intercept for its inverse. Okay? So in this case, unfortunately for this case, my x-intercept, right, they're both going to be zeros. It's going to be 0, 0. X-intercept equals 0. Y-intercept y equals 0. Nope, I wrote that wrong. I'm just going to write this as coordinates because I'm in my own head, I'm a little off. Okay? And so this is our parent function for the cube root function. Okay? I know that's kind of a little bit confusing. So, now I want to kind of show you the, hold on, let's see if I can pull this graph up. Hoping I can. So the graph that is on your, that I posted on, that I posted on Desmos, it looks like this, okay? So the transformations for this function are going to be the exact same that they've been for every single other one. And in fact, we'll notice with the transformation rules, right, my A, H, and K are all still going to be in the exact same place, okay? And they're going to have the same kind of features, okay? So if I increase A, right, if I increase A, right, we'll notice that I just have a vertical stretch, okay? If I decrease it between 0 and 1, we have a compression. And then if I go below 0, we have a reflection, okay? A true reflection across the x-axis. And again, as it gets bigger. Okay? And again, this is on Canvas, so if you want to play around with this and take a look at it, you can, right? The same thing with like h equals 0, with h. So we notice that it's x minus h. If I increase h, right, this moves to the right that many units. If I decrease h, all it does is move it to the left that many units. Okay? And then the same thing's going to be with k. If I increase k, I'm just going to go up. I'm going to go down. Okay? So just to kind of give you some examples, right? If I do some horizontal translation, so again, right, so let's just kind of talk about the first one. All right, where do you think my graph is going to go for cubed root of x minus 1? Is it going to go to the left? Is it going to go to the right? And how many units? What do you guys think? Going to go to the left? Is it going to go to the right? And if so, how many units? For just the very first one in the horizontal under horizontal translation. My h is positive, guys. So it's actually going to go to the right 1 unit. Right? So remember, if it's x minus 1, I'm actually going in the positive direction because x minus h is always, because it's inherently negative. Same thing if I have x plus 3. We should anticipate that's going to go to the left 3 units. Okay? And then x minus 0.5 to the right half a unit. Right? And so on and so forth. To the left 2.75. All right, and there's lots of different things that we can kind of do with these. The same thing's going to be with vertical translations. Now, the reason that I wanted to introduce these ones is it doesn't matter where, right, my k is. It can be in front or it can be behind, okay? So this is the typical one where k just means it goes up 1. This one, it goes down 4. This one's going to go actually up 3 because k is still positive, right? And in the last one, -2 plus third root of x, it looks like we should be going up still because we have a plus, but because k is actually negative in this case, we go down 2. Okay? And then the vertical stretcher and compression I've kind of already showed you guys. Remember that if a is negative, we do have a reflection. If a is negative and between 0 and 1, we have a reflection and a compression. All right. A is greater than 1, we have a stretch. And if a is between 0 and 1, we just have a compression. Okay? All kind of things that you guys can take into account. Okay? So now here's what I want you to do. Again, you who have access to this Desmos. So I'm actually going to pause the video here, and I'm going to start up a second one in just a minute. Right, but I want you to pull out the transformations one. Okay? I want you to pull out the transformations one. And we're going to go, the parent function is x cubed. And here's the ones that I want you to graph. Okay? I want you to individually work on this, and we'll come back and we'll talk about the solutions in just a minute. So I want you to graph h of x is equal to, is equal to 2 cubed root of x minus 1. And then I want you to graph g of x, which is equal to negative cubed root of x minus 2, but the negative is in the radical. Okay? So please, I'm going to give you about 10 minutes. Please go ahead and start. I'm going to pause the video here.